thank you, Vikram. Thanks to PyBay for having me today. This is my first talk ever, and thank you. I'm really, really excited. So let's get right in. My talk is called Reading Python You Didn't Write. And this idea sort of came about because about 6 months ago, I started my first software engineering job at InfoScout. And reading a giant code base is a lot different than creating your own tiny project at a coding bootcamp. So over the months, I just kind of assembled a list of things that I did to immerse myself, and now I'm going to share that list with you. Vikram already mentioned most of the bio stuff. But I work at InfoScout. We are a market research tech company. We have a flagship product that is basically an analytics dashboard for our clients who are mostly consumer retail brands. I graduated from Hackbright Academy about 2.5 years ago. And I did not study computer science in college. I actually majored in economics and then did a graduate degree in real estate and really loved the analysis part of the real estate work and decided I wanted to learn how to do that much more programmatically. And that's what led me to SQL and Python, and this whole world kind of exploded open for me. After Hackbright, I spent some time as a software engineering educator at Girls Who Code and Tectonica, which is an apprenticeship program for low-income women in the Bay Area. And I'm a proud Bay Area native. There's not a whole lot of us, so I like to plug that.
What city?
I was born in Fremont and then grew up in Antioch and graduated from Mills in Oakland. So today we're going to talk about 6 techniques for exploring code that's unfamiliar to you. I do want to be really clear about who I intended this talk for. So as I was writing the talk, I was keeping in mind people who are hoping to start their first job soon, people who maybe recently started their first jobs. Open source contributors often have to just dive right in order to make contributions. And I was also thinking about managers as they support new hires and how to help those new hires get up to speed as quickly as possible. And coincidentally, these techniques meet a variety of learning style needs, so you'll probably find something in here that will work for you and help you out. The 6 things I'm going to talk about all start with D. I was really excited that that happened. Took a little bit of alphabetic massaging, but it worked. So description, diagram, docstrings, dialog, debugger, and documentation, and we'll dive into each of these for a couple minutes. Firstly, let's talk about description. What I mean by this is using the file tree that you often see on the left-hand sidebar of your text editor to describe the hierarchy of the project. And throughout the first half of this talk, we're going to use Taiga as our example project. Taiga is an open source platform for agile project management. It handles Scrum and Kanban options, and it's a Django app, and I, at InfoScout, work on a Django app, so I wanted to keep that consistent. And more importantly, Taiga is a really robust project, and it would be representative of something that you might see in a web development role. So firstly, why would we describe the hierarchy? One thing is that saying information out loud helps you remember it better. It'll also help you to find files faster when you need them if you know where they're organized. And then you could compare this hierarchy to that of similar projects you've seen. So even as I was exploring Taiga in preparation for this talk, I kept making parallels back to the Django app that we use at InfoScout, and there are definitely patterns. So what I'm about to do is just walk you through sort of a small segment of the Taiga app, and I'm going to demonstrate for you how I would say this to myself. So at the very root level of the Taiga project, I would say something like, the first level inside the Taiga back repo contains the root level directories and files. The directories I'll probably use most frequently are Taiga, which is the project repo, and tests, just going off the names. So it's very sort of interactive with yourself. So you're not just reading it, you are intentionally explaining to yourself what it's doing. I would also say for that first level that there's a lot of explanatory markdown files along with the gitignore file and the requirements file. And I expect that because That's what I've seen in other Django projects. So if we drill down a level further, if I decide to go into that taiga directory I just mentioned, I would say to myself, I can go into the second level of that taiga back repo by opening the taiga directory, and that's for the main project. And I can see now that that taiga directory contains a lot of other subdirectories. And each of those seems to be named for a specific part of the app. For now, I'm just going to focus on the projects subdirectory and see where that goes. So I'm really keeping myself focused. I'm picking like one specific path and then just going down that path as deep as it will let me, rather than trying to cover everything all at the same time. When I click into that projects directory, I would then say to myself, okay, inside this directory, there's a subdirectory for each main feature that's available to users when they create a new project in taiga. So here you can see attachments, contacts, epics, fixtures, and so forth. But for now, for our purposes, I'm just going to focus on the epics subdirectory and see where that goes. So I would say, aha, here in the epics directory are all the Python files that are specific to epics. And this is a very good example of good naming, so thank you, taiga. That's to be expected. So I would make an educated guess that for each feature of taiga, the files associated with that feature are going to be similarly nested. So at this point, I don't even necessarily have to look into all the other directories. I can make an educated guess that each of those other subdirectories is going to contain all the files for that particular feature. So we're in the epics directory, and we have all these Python files here. So admin, API, models, utils, and so on. So inside this level that we're in, which is now the 4th level, I'm going to zero in on the models py file. And I would say something like, it looks like there's only 2 models defined here. And so based on the name of those models, I'm guessing that users can link their epics and their stories somehow. And for a first pass at the code, that's probably all I need to know. So here's a map of the directories we just traversed. So we started at the root of the project, then we went into the project directory itself, and then we kept drilling down until we eventually got to something useful, which are these model objects. So that's how I go about describing the hierarchy. It seems like a lot of work, and it kind of is, but if you make the investment up front, it will save you a lot of time later. So the second D on my list is diagram. And for this, I would draw out the main parts of the file tree. So we just walked through the file tree verbally, or maybe in our minds, but for those who are kinesthetic learners, you could actually draw it out instead. What I'll be showing are little boxes from Google Slides, but to really glue this in, you would probably want to draw them out. So we're going to go back to that same file path we just looked at. And the reason why drawing is useful, aside from the kinesthetic learning effects, is that it allows you to visualize the overall structure. So if you're not a person who can keep words in your brain, but you can keep pictures in your brain, this is a better method. And just as we talked about how saying something out loud helps you remember it, sketching or writing that same thing will also help you remember it. So here we have the first level, which we talked about was the root directory of the entire project. And then the second level, which is all the stuff we mentioned before. So we have the taiga folder, the tests folder, which we talked about, along with the gitignore file, the requirements file. At the third level, we have that projects folder that we were just talking about, along with some other Python files and some other directories, and so on and so forth. So highlighted in red, I'm showing all the things that we've just walked through until we eventually get to those 2 objects that we were talking about in the models file. For docstrings, this is something very near and dear to my heart. So the reason why I suggest reading and writing docstrings as part of your, exercises in getting up to speed with a code base is that docstrings allow you to both solidify your own knowledge and share your understanding with future engineers who may be coming to that code base. Let's take a step back and talk about what docstrings are first. So docstrings are those multi-line comments that appear directly under a function's definition. We'll start with 3 double quotes. And what that information is telling you is what arguments the function needs to receive in order to operate, what the function itself accomplishes with its code, and what information the function is going to give you back when it's done. So those 3 things will almost always need to be in the docstring. Docstrings actually have their own style guides. So just like we have accepted style for Python, whether it's PEP8 or something that's specific to your company, docstrings also have those style guides. And so I've put a couple examples here. So we know PEP8 as the Python style guide, but PEP257 is the Python docstring style guide. And it looks something like this. So typically the first line is a very brief explanation, and it ends in a period. If you need to add more details, you would skip a line and then write to your heart's content. And then we describe what the arguments are and what the what the function will return. Google has their own docstring style guide. It looks slightly different, but the pieces are all the same. And in Taiga, they use yet another style for docstrings, which you'll probably see as well in other open source projects. So with this one, for example, this is for a function called attach closed milestones. I have no idea what this function does, but I can read the docstring and learn, okay, it attaches a closed milestone counter to each object of the query set. Great, that might be enough for my purposes. Okay, why write docstrings? It's actually, it can be quite a lot of effort to write them, but the reason we do it is because they're notes to your future self, and you want to be kind to your future self, and so you should be proactive about writing docstrings. So as an engineer new to a team, when you do get to the point where you're adding new features, adding new features and consequently adding more functions, you want to take the time to write docstrings along with the function. And in fact, some people would even argue that you should write the docstrings first. The reason would be that you would describe in the docstring what the code is supposed to do, and then write code that accomplishes that, rather than writing docstrings that describe what an existing function does. Because if you do that, you may be unintentionally codifying in your docstring non-essential behavior in the function, or perhaps buggy code that exists in the function. Another reason to write or maintain docstrings is that incremental docstring maintenance improves the documentation of the code base over time, especially if you're using something like Sphinx, which I'll talk about in a minute, to automatically pull your docstrings out of your project and assemble them in a reference document. So when to add new docstrings? If a function doesn't have one, you should probably add one. You would use a one-line docstring if the function is small and what it does is pretty obvious. It would probably be overkill to write that multi-line comment that we just saw an example of. But if it's not a simple function, you'd want to write a docstring that adheres to your team's style guide. Most teams have one. It's probably either PEP257 or the Google example we saw, but if it's not, as long as the style is consistent across all of your team's code, you should be fine. Another thing you can do is to improve existing docstrings, and this one I think is actually quite valuable because you have to understand what the function is doing before you can write about it. And so that process of understanding what the function is doing is going to force you to use a lot of the other suggestions in these slides. So when you find a docstring that's unclear, or it's outdated, or incomplete, or stylistically inconsistent, you should fix it. Your team will thank you eventually if they ever notice. So that's about docstrings. I think another good one for me is dialogue. I really like talking to people, especially about code. And especially talking to someone about the code when that person wrote it or they are intimately aware of how it works. And this one seems pretty obvious, right? You are working on adding a new feature or fixing some small new bug, and you get stuck. Of course, you're going to have to go ask someone for help. But I think there's a very strategic way to go about doing this. So when I talk about talking about the code, what I mean is that talking about the code is different than being told about the code. So I could go to someone and say, hey, I'm trying to implement such and such. Can you explain to me how this other piece already works? And they could tell me and I could understand and that would be great. But having a conversation about it is actually much more useful for me and perhaps much more useful for the other person because through the process of explaining it to me, they're getting the benefit of sort of relearning it in that moment or solidifying it in that moment. When you're engaged in conversation, you are, in fact, more engaged. You're not just passively listening. You're actually actively participating. And you can also focus the conversation on what you need. So rather than another engineer telling you how something works, which maybe you already understand, if you are actively engaged, you can guide the conversation in a way that's useful for you. This is a really good opportunity to ask questions, clarify what you know. Also share what you already know. It may be important for your conversation partner for them to understand that you actually do know stuff. You don't want them to necessarily think that you haven't done your homework, right? So here's a list of conversation starters. Maybe they won't all work for you, but here's a starting point. So you could ask a more senior engineer to help you understand how two parts of the code base interact. Often someone can explain to you in 30 seconds what might take you 2 hours to figure out on your own, and I think most people would agree that that would be a good trade-off, that they would not want you spinning your wheels for 2 hours when someone could help you out really quickly. Another conversation starter that I use a lot is, how can I make my code cleaner and easier to understand? So as an early career software engineer, I find that I'm almost able to write code that works and it gets the job done, but I'm not just interested in writing code that works and gets the job done. I want to write really Pythonic code, and I want to grow to be a software engineer that is respected for the way that I write code and how it fits in with a larger project. Another thing that I really like to open conversations with is, could you share how you went about creating that new feature? So I work on a product where pretty much every week we're adding new stuff to our dashboard for our clients, and I find some of the new features really fascinating. I don't have the skills yet to implement them, but just having conversations with the engineers who are working on them allows me to sort of peek ahead at what I might need to learn in order to start doing the more challenging work that they're doing. Another really good one that I like is, could you tell me about why the team decided to blank? I really like the way that this question is worded because it puts forth it kind of says that I've thought about why you might have done this already, but I either want to confirm or refute that. And it's such an open-ended question that hopefully the person you're asking it to won't feel defensive, or they won't feel like you're attacking their decision, but rather inviting them to explain it to you. And lastly, another conversation starter, what should I be planning to learn in the next few months to start making larger contributions? So there's a fantastic blog post written by Julia Evans, who's pretty prominent in the online coding community. It's called How to Ask Good Questions. If you don't do anything from any of the links that I've put in this talk, but you read this, I will consider my time spent up here a massive success. The reason why I like it so much is because, one, she has comics, which is pretty cool, and also it's just really useful. You know, as engineers, we are often not expected to know everything, but we are expected to figure it out, and to do that, we often need to ask very precise questions. And so She gives a framework for doing that, and I've put the main points here. So state what you know. It's important to tell the person you're asking sort of what background you're bringing to your question. Ask questions where the answer is a fact, not an opinion, right? So an example of probably a not so good question is X or Y better? You might say, what would the ramifications be if we chose X over Y, right? So that slight twist in language probably is going to give you a more useful answer. Number 3, be willing and able to say what you don't understand. Sometimes it's really scary and terrifying to admit that you don't know how to do something, especially if you think there's an expectation from your team or your manager that you should already know how to do it. But you have to get out of your own way and just admit it, and it's going to be uncomfortable, and then just keep going. Talk with the person you're in conversation with about things you don't understand, and be brave and ask them to explain certain concepts to you or certain vocab. They are probably coming in with this expectation that you may know something, and they may be using vocabulary they think you know. But if you hide that you don't, again, you're just getting in your own way. Number 5 is decide who to ask. Sometimes it may be the case that you have a question and you just put it in your team Slack channel, hoping that someone somewhere will answer it as quickly as possible. That's actually not always the best use of your team's time, because what ends up happening is you interrupt 15, 30, 100 people who all briefly click over to that tab to read your message. What's probably going to be better is to isolate 1 or 2 people who have expertise around that question topic and ask them specifically. So that's what number 5 means. Number 6, ask questions to show what's not obvious. This goes back to helping your conversation partner understand the expectations that they may be bringing into the conversation. Restating your new understanding to confirm. I do this all the time because I want to make sure that I don't have to come back to a senior engineer in 5 minutes because I've forgotten what they told me. Number 8, keep your eyes and ears out for questions you can answer. So even if you're new to the team or completely new to software engineering, there is stuff you know. You have knowledge, right? You've either gotten it from your coding bootcamp or you've gotten it from your 4-year degree program. You have power to answer questions, and I think it's great to, again, just like it says, keep your eyes and ears out for opportunities where you can get the conversation to go the other way. So here's a script I put together, and I've actually used this in all of my teaching to sort of train my students on what to do when they need help. Because what I don't want to happen is for a student or a colleague to raise their hand and say, it's not working, what do I do? As a helper, I have no idea where to start. So the script goes something like this. Hi, name of person. Thanks for taking a minute to help me out. I'm trying to do this. What I expect to happen is this thing, but what's actually happening is this other thing instead. To try to solve this on my own, I've already done A and B and C, but none of those worked because blah. What would you suggest I try next? So I have a fleshed out example now. So hi, Amy, thanks for taking a minute to help me out. I'm trying to figure out what tests to write for the new class and methods I added for the new feature I've been working on. I expected that I'd need to write unit tests for every new method, but now I'm realizing that may not be the best approach. Maybe I should write integration tests for the functions that call those methods instead. I've looked at other tests we have as examples, and I think integration testing is the way to go, but I just want to be sure. What are your thoughts? This has always been an incredibly effective way that I've asked questions. All right, let's get into the debugger. So effectively, a debugger is any program that you sort of run your program through, and the debugger is going to halt the execution of your program when it reaches a particular place, and then allow you to mess around with the variables. That explanation came from a really great Stack Overflow thread I found. There are a number of ways to use debuggers. Pretty much every language has them. The 2 common ones I came across for Python are PDB and, is it PUDB? or PUDDB. I'm not exactly sure. I haven't tried it yet. I use PDB. PyCharm also has a built-in debugger. There's lots of other debuggers you can use. I gave a link to some. The reason why we use a debugger is that it allows us to step through the code line by line. So I gave you a whole bunch of tips already for what to do, but we haven't even gotten to the part where we're actually writing code yet. So debugger is where that comes in. Once you get to the point in a new role where you are adding code, the debugger is going to allow you to step through it line by line, and you can test what it does versus what you expect to happen. You can verify assumptions, you can experiment with variable values and find out where exactly unexpected behavior is coming from. This is also especially useful when you are modifying code that already exists, and it worked perfectly before you touched it, but now you're adding stuff and changing the functionality and you break it, so you would put in a debugger statement and go from there. I did put together a video about how to use PDB. For the sake of time, I'm going to skip it. If you haven't used a debugger yet, I would highly recommend going on YouTube and finding a video for this. Mine's about 5 minutes, and we just don't have time. Last one, documentation, reading it and writing it. Also, I just want to say I've been really impressed by how many speakers this weekend have talked about the importance of documentation. It makes me very happy. Okay, let's talk about what documentation is and is not. It is not just one document. It is not just docstrings. And it's also not a link that you send to someone in Slack to a thread that you sent to your teammate last month. It is, however, made of 4 different resources, and this was actually a new concept to me. But last year, I spent a lot of time watching old PyCon videos and came across a couple documentation-related ones by Daniel Procida. And I'll link to some of his videos in a minute. But he puts forth an idea that, indeed, documentation is 4 separate things. So we have tutorials, which are learning-oriented, and those will walk you through step-by-step how to do something that's kind of more complex, right? So how to set up a Django app, for example. We have how-to guides, which are much more specific. So an example of that would be how to set up models in Django. And then we have reference, which is information-oriented, and discussions, which would be like FAQs or chat rooms or things like that. So Python has all of those and more. I've highlighted here they have a tutorial, they have the language reference, the how-to section, and then FAQs. So most of the time when people are talking about the docs, or they say, just go read the docs and figure it out, what they're actually talking about is the reference. And most Stack Overflow threads that you come across when you need help are actually how-to references. They're telling you how to do something very specific. And many Stack Overflow threads are also discussion resources. I have found as a new software engineer that most of the time what I need are actually tutorials and discussions. I kind of need more context that a tutorial provides, and I also need a sounding board to talk about what I'm doing. One thing I do suggest when you start a new role or you start working on a new open source project is make a list and keep it in one spot of all the places you can go to find documentation for that project or that team. Just keep everything all in one spot, so when you get to a place where you're stuck, you're not spending your energy crawling all over the internet trying to find things. Okay, why do we read documentation? Firstly, you want to choose the right resource for what you need. We just talked about how there are 4. Make sure you choose the right one. You want to see if someone has already answered that question. You might also want to prepare yourself before you ask for help. Give yourself some background. You could read the documentation to learn what interesting features are available in that language or library, and also because it's fun. The process of writing documentation means you have to explain how to do something, and in order to explain how to do something, you have to know how to do it, and explaining is going to make you better at that thing. Incrementally adding documentation, even if it's once a week, is going to keep that documentation as a whole current. And it adds value to your team because a lot of people don't like to do it. So if you're one of the people who does like to do it, your team will probably be very grateful to you, and you'll be making the developer experience on your team incrementally better. A really quick reference to Sphinx, which is a third-party package you install with pip that effectively scans your project files, pulls out all the doc strings, and puts them into their own HTML web page. Highly recommend checking this out. It's pretty cool. I have some links here to those videos I was mentioning about documentation by Danielle Procida. And I'm cruising in right under the wire at 20 minutes. So today we talked about 6 techniques that all happen to start with D for how you can explore code that is unfamiliar to you. Thanks a lot for being here.
That was an amazing talk. A lot of takeaways from the talk. And I have to mention, if you haven't already, if you aren't following Julia Evans on Twitter already, she has some great resources on Twitter. So I definitely recommend that. So we have time for 1 or 2 questions, if anyone has questions.
Yeah, you had some great advice about how to ask questions. I have to answer a lot of questions, and I'm sure, there are things that you've noticed about like ways that people can answer questions that's more helpful, and maybe ways that people can answer questions that are maybe unhelpful. Do you have any tips there?
Sure. I can only speak from my own experience. I always appreciate when the person answering the question says, are you already familiar with blank? I like the way that it's phrased because it makes me feel like even if I'm not familiar with it, i.e. I don't know, there's room to say. So I think that's a good place to start. I think also like gauging how the question asker is responding to your answer could be helpful. If they start to glaze over, it might be an indication that they have no idea what you're talking about, or if they start to get frustrated, it could mean that you need to rewind and come at it from a different angle. So those are the 2 that come to mind. Thanks for your question.
Any other questions? All right.
Thank you.
So let's thank Erin for this talk.